Thank you to our sponsors at Lexicon and SkyPoint Cloud. Sandeep, drum roll, please. It's your time
Thank
to
you.
shine.
Thank you very much, everyone, for joining me. And thank you, Portland Power BI User Group. I think this is my second time joining you. Always fun to be here and glad to be here. I am definitely a subscriber of your YouTube channel, and I always recommend it to everyone, especially for your diet stuff and obviously Brian's DAX stuff. So yeah, keep that coming.
Melting our
Okay.
heart. Thank you.
So yeah, about myself, I'm going to keep it very short. So I'm a senior Power BI architect at Hitachi Solutions America. Hitachi Solutions America, my employer. So I joined just a little over a month ago. So we are a Microsoft Gold partner, 100% focused on Microsoft and anything and everything that has Azure. Before it, after it, anywhere we do it, including the Power Platform, Power BI, modern data estate, transformations, migrations, solutions, everything. So definitely check that out. I blog at powerbi.com. Easy to remember, right? Power BI, Power BI, my last name. And I am very active on Twitter at Power BI. So if you are on Twitter, hit me up, follow me, and connect with me. I'll be glad to follow you back as well. So the topic for today is leveraging key influencer visual. And the reason why I chose this topic, and I've spoken about this in the past as well, it's been a while. And the reason why I chose this topic is because there is so much that this one visual offers. And um, Microsoft documentation doesn't do justice to it. So I said, why not spend one entire hour talking about it, going into the details, how exactly it works, when it works, uh, how you should use it and how you should not use it, because I've seen it being misused. I've seen it being um, uh, used very skeptically as well. So my goal for today is to give you an understanding as to how this visual works, so that you can use it confidently in your next project. And more importantly, also keep in mind um, when to not use it, because the tendency to misuse it more often than not use it at all. As I go through the presentation, if you have any questions, so Tina or Greg, feel free to interrupt me. I'm not going to monitor the chat, but if there are any questions, feel free to interrupt me and ask the questions. Also, I'm going to keep the technical terms to as minimum as possible. But if I do use something like statistical terms or data science terms, and if you're not 100% sure what that means, let me know, and I'll be happy to clarify that. But today we are going to keep it very, very simple. And I'll try to explain it in plain English as much as I can. Now, the key influencer visual, it's a Microsoft, or you'll see it often called it in blogs as it's one of those AI visuals, the artificial intelligence visuals. So there is a little bit of a data science and statistics element to it, and we will look at that and understand what exactly is going on there. So if you are not familiar with statistics or data science part of it, don't worry, that's why we are here. Okay. So let's start with a typical average looking dashboard that I created just 15 minutes before this presentation. Nothing crazy going on over here. So let me show you the data that I have so you can get a good understanding. A typical transactional fact table data. So we have order priority, discount, unit price, customer name, and blah blah blah. All the nice things that we usually deal with in a BI dashboard, BI report on a day-to-day basis. And always, almost always, the goal is to create something, as we call it, providing actionable insights, right? And that's one of those terms that if you ask 10 people, it will mean 10 different things. So what does actionable insight usually, what does it really mean? So if you ask me, the insight would be something you have the data, and usually 99% of the times it is backward looking, it historical data. So we have, in this case, for example, profit by different products, then the profit by product category, then some mapping going on, and then some sales trends, and things like that. And when you present it to your users, the idea is that we have something that has happened. Now, let's try to understand what has happened, and are there insights that we can gather from it so that we can act on those, and then make better business decisions. And there are two components to that I said. Insight, that would be something that is not very obvious and something that is very practical that you can get out of your data, and then use it to make some business decisions. But the one thing that's often forgotten, and not much paid attention to, is the speed to insight. Meaning, we have the data, we have the visuals. If we spend a lot of time digging through the data, we will find those insights, right? And that's the whole goal about, with all the drill throughs, with all the bookmarks, and all the stuff, so that your business users can slice and dice the data, understand it in 10 different ways, up, down, in all the directions, and then maybe find that negative information, maybe find that negative insight, so that you can act on it. As an example, in this case, in this data set, we have the sales transaction, and we also have the returns along with that. So there are some customers, or lots of customers, who have returned the products as well. And maybe in this case, the person or the business user who is using this report, they want to understand, where are those trends? What are those things that are driving those returns? Usually, what we would do is, maybe I used a field parameter here and then say, okay, let me give my user the ability to maybe slice the data by region, and then we have it by region by count. So the number of orders that were returned versus not returned, these are in absolute terms. So these are all the counts. So the next question to you that the person might have is, well, I'm looking at the count, but what about, should I be looking at the count, or should I be looking at the percentages? Because that may make more sense, because maybe somewhere like in central region, they have 15 over 2884. So whereas in the south region, we have 7 over 1947. Well, maybe, like, let's look at it by product category. Same thing. Let's look at it by, you get the idea, right? And they could be spending a whole lot of time digging through the data, and maybe trying to make sense of the data and understand, what should we really focus on. And this is where the key influencer part comes in. This is one of those visuals that will help you and your business users get some insights into the data, so that you can achieve that speed to insight. It won't be the whole insight, but at least it will give you uh, some guideposts, some direction as to where maybe you should start looking, instead of randomly slicing and dicing the data. Now, I'm going to assume all of you know what exactly the key influencer visual is. If you do not know that, let's go ahead and let me show you. So let me get rid of what I currently have here. Let's go right here. If you go, and it is one of those native visuals in Power BI with these three lollipop bars. When you click on it, it's going to ask you on the right hand side three things. The first thing is analyze. What do you want to analyze? Second thing is explain by, that whatever you're analyzing, what do you want to explain it by? And then expand by. We'll first look at both of these, analyze and explain by. And then we'll talk about expand by after that. So in my case, what we want to understand is the returns, right? So I'll go to my data, And then I have status. The status has returned versus not returned. Let's go to orders, and then let me show you the status. Yeah, so we have returned and not returned. Very simple. And that's what we want to understand, right? So let's start, and then I just drag it into this whale that analyze status. And what do we want to analyze it by? So I am going to just drag the columns that I think I want to understand the return status by. So I'll start with city, for example. So I'll add explain it to me by city and keep your eyes on the left-hand side here. So I'll start with city. I'll start with maybe customer segment. Okay, so something came up over here. Let's see, order priority. Let's go next by a product category and then product container, maybe. I don't know what product container is, but then product subcategory. Let's say region, and then maybe shipping mode, state or province. That would be good to know. So it created something, it did something, and it created a nice looking visual for us. Can you still hear me?
Oh yeah. Oh yeah.
Okay, so I just got recharge your battery. So
Okay.
I don't know, maybe
Go for it.
my headset might die, and in that case, let me just make sure that I can use my laptop.
Yeah, no worries.
Okay,
Give it a shot.
let me try this. Um, can you still hear me?
Yeah.
Can you still hear me?
Uh-huh.
Okay, good. Okay, I'm gonna use my microphone here.
Okay. It's not that bad.
Okay. Um, yeah, so we have this, and it created a very nice looking visual for us. And now our goal is to understand what this visual is telling us. And we can do that by going from top to bottom and left to right. So the first thing you will notice that we have two tabs here, the key influencers and the top segments. So you'll always see these two, so top segments and key influencer. And both of these serve two different purposes. Okay. Key influencer, then at the bottom, it says, okay, what influences status to be? And you'll see two options, return versus non-return. And these are the options that we saw that were under status. If it was something else, maybe it had three different options here, return, not returned, and maybe none. Who knows? Then you will see three different options here.
A quick question, Sandeep.
Yeah.
Fernando was asking, so analyzing the object visual is a categorical variable. Is that correct?
Yeah, that is correct. So we will talk about that as well. Question. So in this case, yes, it is a categorical variable, and that's why it has two states. And if you are wondering what a categorical variable means, the categorical means it's a text as opposed to a numerical field. And we'll look at both examples of that. Microsoft has made it, Power BI team has made it very easy for you to read it. And all you have to do is just follow along. What influences status to be returned? And so that's the question. So you have a question mark. When, and then you go down, state or province is District of California, then the likelihood of status being returned increases by 4.61x. Now let's try to understand what exactly that means. Actually, when you hover over it, it also gives you a nice tooltip that you can get that when the status, the state or province is DC, the status is 4.61 times likely to be returned, and so on and so forth. On the right-hand side, you see a bar chart, and these two are completely different things, okay? And this is often confused because the numbers don't match. In this case, it's even worse because the numbers do match. You kind of see 4.61x, and you also see 4.5%, but this is not related to this, and we'll discuss that as well. You can click on each of these different variables or features or metrics that are available here. And you can also click on these circles. Okay. So what this is saying that when the district or when the state is DC, District of Columbia, this is an important point to keep in mind. Controlling for everything else, meaning we are in statistical terms, we are controlling for all the products, we are controlling for all the regions, we are controlling for everything that we have put into this explain by bucket. And now we are only looking at District of Columbia, then the likelihood of the product being returned increases by 4.61 times. Now, what does 4.61 x mean? Is it compared to California? Is it compared to Massachusetts? What is it compared against? And the answer to that is it's 4.61 times 4.61x compared to not being returned. And that's important to keep in mind because that's one of those things that often is confused, that when it says that it is 4.61 times, then it is not compared to anything else. It's just comparing itself, but compared to the other option that's available. So where does this 4.61x come from? And here is one of those times that I'm going to have to explain with a little bit of equation here, and we'll keep this thing simple. So what Power BI is doing in the background is it's running a logistic regression, and I'll explain that. But just focus on the left-hand side and the right-hand side. On the left-hand side, notice, forget about this log, but focus on the top. So P divided by 1 minus P. So if my return, not returned is, for example, P, is not, returned is P, then not returned is 1 minus P. So we are talking about the ratio, the odds ratio as this is called. So P divided 1 minus P is equal to, in regression terms, it creates a regression, right? So it creates that something multiplied by x, and this x in this case in regression is all these variables that we have dropped into the explain by bit. So imagine the x that I just talked about. The x is nothing but, let me make this smaller. The x is nothing but, so the way what Power BI is doing in the background is this return divided by not returned is equal to, forget about the beta, but is some value beta multiplied by x, and that x is, for example, city, and this thing will go on, and it will be plus beta multiplied by customer segment, and then order priority. And if you notice, it is X, meaning all the other things are not taken into consideration. And that's why when I said that it is controlling for all those things, so what this is saying is this beta is this 4.61. So the easiest way to read this is, imagine your this beta naught is not there and X is 1. Okay. When X increases by something, then this beta, because it is 4.61, your ratio is going to increase by 4.61. Makes sense, right? So the P divided by 1 minus P is equal to 4.61 times this variable that we are talking about. So this 4.61 is the odds ratio of something happening. Now, when I said that it is controlling for everything else, what that means is what Power BI is doing in the background, it's controlling somehow for rest of the variables, and it's looking at one thing at a time. And there are implications of that, and there are limitations of that. But it's controlling for all of those different things at a time. So it's going to segment the data, and then it's going to control for everything. And then it's going to look at, okay, what makes the biggest impact on the status that we are considering over. Okay, so this is an important point to consider, and if you have any questions about that, and if it doesn't make any sense, please let me know. You will also notice that on the right-hand side, when I selected DC, it's highlighting DC, right? When I select California, it's highlighting California. Now, the difference between what we have on the left side and the difference and what we have on the right side is the left side shows the impact, the beta that we're talking about, the impact that that particular variable, that particular column, is making on the thing that we are interested in. Whereas the right-hand side is just more for your understanding that, okay, out of the whole data set that you have, what is the proportion? So in this case, although state of California, it's making 4.21 times impact. But if you look at it, it only accounts for only 3.23% of the overall returns. So this is just your normal bar graph. If you did not have this, you would only be looking at this. And if you were to plot or create a bar chart with your cities or the states and then the percentage return on the y-axis, that's what this is. This is more of a convenience so that you can understand what this is. The way Power BI decides whether to include that on the left-hand side is based on this horizontal line. And it's kind of hard to see, and I wish that they had done a better job with this, but the average excluding the variable. So when I select the District of Columbia, excluding District of Columbia, the overall average, the percentage average for returns is 1.02, but actually for DC, it's 4.41. And that's why it selected District of Columbia as the influencer. Anything that is below that red line, so anything that's below the average, will not be considered as an influencer. In fact, if you see at the bottom here, only show values that are influencers. If I check this box, you'll see everything else goes away, right? So you can just select this and it will only show you the factors that are important for the thing that you have selected. So if I go to region West, it will compare West versus East. If I go down, it's a product container, it will do that comparison for each of the columns that are selected, not just across across all the variables or all the columns. Okay. So how would you use this? We started off with the question, where should the business user start looking at, right? And now we sort of have an answer that maybe they should start looking at District of Columbia. And the reason being, when the product, the probability or the chances or the odds, and that's the right term to use here, the odds of the product being returned are 4.61 times higher when the customer is, or when the product was shipped to District of Columbia. And then maybe that might spark some discussion as to why District of Columbia, why DC, what's so special about that? And you can go on doing your analysis from that point onwards. Now, don't take this thing as too hard to say we will focus and then maybe deploy our resources in DC, or maybe we should do more hiring or do some quality control and things like that in DC. That's not the takeaway here. Because the other angle that you have to look at this is, if I zoom in, if you see that there is a one tiny bit thing right over here up at the top, and then you will see it on around the other circles as well, right? Do you see this? And this is a very smart thing that the Power BI team did, is because there are two different things. So something could be making an impact, but the overall proportion of that thing in the overall data could be very, very small. And that's exactly what is happening in this case. So when I hover over it, you will see that although the status is 4.61 times more likely to be returned, this influencer contains approximately only 0.68, so less than 1% of the entire data. Now, these two things are odd, right? That how would it be possible that if you were to do a traditional BI analysis and BI reporting, we would maybe do a sorting and then do it based on the descending order. so that wherever is the highest percentage, it will go up at the top and we'll start looking at that. And this is where this visual adds value, because we are not only looking at the count and the percentage and the proportions, but we are also looking at the impact it's making based on the statistical analysis that the visual did on the data. But you have to take the two things together. So there is no right or wrong answer here, or one clear-cut 100% answer, because DC and California are so close that you might say, well, DC, yeah, 4.61 times of being returned. But look at California, it's 4.21 times. So it's higher, or it's almost the same orders of magnitude. But the overall proportion, because I'm looking at that the periphery, the overall proportion of the orders returned is significantly higher. Again, if I look at this, it is 0.68, so less than a percent. When I hover over this, it's 10 points, so 11, about 11% of the data. So that added a little bit more context around that data point. That maybe what we should do is, yes, we should investigate DC for sure, but at the same time, California is way high up in the order of factors that are influencing that particular category. And on top of that, it is also proportionally very high. So maybe look at California. I would look at California even before DC. Now you might wonder, okay, so where, if this is small and then this is, even small, well, bigger, and then it gets smaller again. So where exactly is that based on? So there are two ways to do that. And that's in the settings. So when I click on the visual and then go to format visual and then look at the analysis, you will see right here, count type. Right now it is relative. When it is selected as relative, then the region West, for example, it is showing to be a full circle. And it's full circle because it is 24%. So it's taking 24.36 of the whole data or the overall return as 100%. And then the rest of the circles are in relation to that. So that is one way to understand, okay, where exactly is that in relation to the rest of data. Or you can make that absolute as well, if you care about the total number of data points.
Perfect. Sandeep,
Relative,
oh, sorry,
yeah.
Sandeep, I'm going to chime in real quick with a question. Silk asks, I'm curious, how do you assure that users of these reports where you include this visual understand how to use it?
Yeah, we'll discuss that as well. Okay. Um, so that is one way to understand that. On top of that, there is another thing that you can do. At the bottom, there is a sort by, and right now it is sorted by the impact, and that impact is 4.61x. And then next to that is the count, and the count would take into account the overall count that we have. So now you see the state of California, it is higher, or it is shown to be higher, 4.21. And in DC, because that's the DC was selected. And so that's how this part of the visual works. There are other options that are in here. So what Fernando said about categorical. So right now this is categorical, but if this was where this will play a role is, imagine you have a flag in your data that returned is 1 and not returned is 0. In that case, it will show you both numerical as well as categorical, because it is 0 and 1, right? We are not interested in 0, 1, 1, predicting 0 or 1. What we are interested is the categorical aspect of it. And that's where you would use that instead of hey Power BI or hey Influencer Visual, instead of treating this as um, uh, 0 and 1 numbers, treat it as categorical, so that it will be used as a categorical variable. Okay. Next to that is the top segments. And this part is, I think, one of the most underutilized parts of the key influencer visual and as well as the Power BI, because I use it so often and it is uh, so helpful. And the amount of insight that you can get out of it is you will have to spend a whole lot of time writing Python and then understanding it and slicing and dicing. And this top segments does all of that for you. The key influencer is based on logistic regression. So it's doing regression analysis. The top segment, it works on random forests. And if you're familiar with the term, so it works on random forests, and what it's actually doing is doing clustering. It has nothing to do with the impact that we were seeing earlier. So 4.61 and all that impact that we were talking about, all of that goes away. The segment, as the name suggests, it's completely segmentation. So this is clustering plus segmentation kind of thing that's going on. Even at the top here, when the status is more likely to be returned, we have this as returned. You will see a number of different bubbles coming up here. And then at the bottom, it shows you the segment. So this is segment number 1, this is segment number 2, and this is segment number 3. Okay. Then at the bottom, you will see the percentage status return is 3.2%. So let me give you again a baseline here. We're talking about the average, overall average of the returns, percentage return is 1%, which is what I'm seeing here, 1.02%, right? What the segmentation, what that does is, imagine we have, if I were to show this in a 2D or maybe even in 3D, let's say do it in 3D. I have all these customers, right? I have all these customers who are some in California, some are in DC, some of them purchase envelopes, some of them purchase some heavy equipment, some of them use air shipment, some of them use this, that. And all of these, there are lots of different permutations and combinations, which is what we saw earlier. So when I went here, I looked at one single thing at a time. But if we were to build a hierarchy of region and then maybe state and then the city and the product category and the product. So if you were to create a matrix with all these different subcategories and then sort it, we will likely see that maybe one of those segments has higher percentage return compared to everything else. What Power BI is doing for us is actually it's going, scanning the data, and then it's doing all those permutations and combinations of all the different various things we have, all the possible combinations of that exist in the data, and then it calculates that percentage return for all of those different combinations. And then it's giving us the top segments, the top 3. It could be sometimes it may give you top 5, top 10. I don't know how it decides whether to show 3 or 5, but it will show you the top segments where we have those higher returns. Okay, so where does that help us? If you see at the bottom, it's telling us I have overall, I think like 20,000 or maybe overall number of rows. Out of those 20,000, there are 1,000 rows where the status return, the percentage return is 3.2%. Remember, our average is 1%, whereas this subpopulation has much higher than anything else. And we can click on it and then figure out, okay, where is it? Now, in this case, just so happens that in this case, it's California, where it is 3.2%. And then the visual also gives us the ability to, again, deep dive into California. Now the California part is selected, right? So let's go deep into California. In California, it's showing me now 3 cities: Los Angeles, San Diego, and San Francisco. And it's showing us the distribution. So the idea here is that now that the question that we are trying to answer is, do we have any population, subpopulation, or segment in our data that has higher percentage or status of being returned. And now that we know what that is, give me more details about that. Are there any subpopulation below that that maybe the key influencer visual hasn't taken into consideration? And the only reason why I didn't go deep into this is because it would have to split the data. When I say random forest, it will have to keep it's a forest. It's like a tree and decision tree. It will have to keep splitting the data and if you split the data too much, you won't be able to, statistically, you won't be able to um, get enough information because, maybe Los Angeles or even in this case, for example, San Francisco, there might be only 10 customers and you may not be able to infer too much out of it. That's why it did not split the data to that level, to that node. But Power BI is letting you browse that data, letting you get a feel for that data by providing more insights from that. So out of that 3.2% for entire California, are there any more subpopulation within that where there might be more interesting things happening? So in this case, for example, it says city, Los Angeles, it accounts for 20% of the records. And then compared to overall California, this is what it looks like. So it turns out that even Los Angeles has even higher than anything else because it's greater than. So the gray bar is California, blue is Los Angeles. And you can go through this. Not all of these would be interesting, but the idea here is for you to go through this and understand. Now, coming back to the question as to how would you use this for your or explain this to your business users? And I'll tell you, I've never put this visual in production in any of my reports. And the reason for that, so I wouldn't put this in front of the business users at all. And you'll probably see reports where you will use it. I personally feel that the key influencer visual is something that it's more for me as a developer to use than for the business user. And the reason for that is because it is a statistical technique, it comes with a lot of limitations. So, and you have to understand what those limitations are. So we cannot use this in every single scenario, and I will show you an exact, in fact, if you look at the tabs below, edge cases, outliers, and there are a bunch of other things that I will be showing you where the key influencer visual actually fails to work. So I wouldn't use the visual. So I would rather use it for myself to understand what are those things. And the idea being that your business is not going to change significantly. So it is just good to know that what are those factors that I should think about. So when I said that in my dashboard, uh, should I slice it by this? Should I slice it by that? What kind of hierarchy should I provide? What kind of maybe should I show it by different segments, or what should I exactly do? I would make those decisions based on that, and then use this as a tool, and then show it to and use that in my visual. Okay, so sorry to disappoint you there, but as always, it's one of those cases where it depends is not an answer. I can pretty much tell you that I wouldn't use the visual for my business users because it's hard, it's confusing. We just spent 20-30 minutes just talking about what all these different things mean, right? Um, a sales manager is not going to understand any of those things. So how would you use even this thing, right? So if I go to segment number 3, if you look at this, it is telling me that the customer segment and the priority and all of these different things, when you take a look at that, then it's account for 2%. I would rather do this visual and then set up a meeting with my business user and then show them the insights, walk them through the insights, and then explain them, this is what I'm seeing from the data. does any of this make sense to you? And give them more pointers rather than as an exploratory tool, rather than giving them if they feel comfortable and and if you give it to them with a big disclaimer that it could be wrong, then that's fine. But other than that, I wouldn't deploy this across the board throughout the enterprise. Okay. So we talked about the key influencers. We talked about the segments. Another way in Power BI that you can segment the data is uh, based on the decomposition tree. And one of the questions that I guess is I was asked in one of the sessions I did was, how is it different from the decomposition tree? So let me show you. So in this case, we're looking at the same data, but instead of the categorical, instead of the text, I'm using average sales. Okay, so I just pulled sales and I'm just using implicit measure here, and it's average of sales, exact same thing explained by. And now if we see over here, instead of what we saw the status, it shows increase or decrease, because now we are dealing with sales, which is a numerical quantity. So now it's doing linear regression rather than the logistic regression. Okay, and it shows increase or decrease because that's what we are interested in. The sales, what are the factors that will make it go up or make it go down? Let's look at the segments here. In this case, let me click on this. You'll see that the average sales is 950. Zoom in, 950. Power BI found one segment, so it just only found two segments in this case. Two segments. One segment has an overall average sale of $3,000. So let me click on it. And it is product container is jumbo drum, and then the shipping mode is delivery truck. So again, same thing. Out of all the possible combinations that we have shipped, there are 698 total orders that had overall average sales of $3,000. That's good to know. Well, we can get to that exact same thing from using the decomposition tree as well. So we have a decomposition tree, and a decomposition tree, which is here, this tree looking thing, I'm doing analyze by, and then explain by product container and the shipping date. And then you'll see 950, which is what we saw. Overall average is 950. If I click and say hi, that what will make that average sales number high? Show me that, and it will say jumbo drum. When I do the next leaf, it will take me to delivery truck. And now look at this, 3,000 and then 3,000. And it is showing jumbo truck and then the delivery truck. The exact same thing that we got out of this jumbo truck, the jumbo drum and the delivery truck. It works the other way as well. So if we have the other one that says it's not a jumbo drum, but it is a delivery truck. So if I were to go here and then say, show me that is delivery truck, shipping mode, delivery truck, and then I value 2889 and not that one. So 2700 and then 2700. So those numbers match. So you can get to the same thing with the decomposition tree as well. So if you want to convey that what are those segments within pockets within your data, then decomposition tree is much better because it's visual, and then you can explain it to your business users as well. Where this helps though is because it points you to where you should be looking at. So right now it only gave me 2, right? But it may give you 5. And it may give you maybe something about expressed air. And then you can click on each of these different segments and see maybe if there is something around express air, or what are those different combinations. So this is again something that we would use as an exploration tool for you to understand the data, explain it to your business users, If somebody gives you the data and tells you, okay, tell me what have you understood? What are the insights that you have drawn from this data? My first thing that I would do is sanitize the data, clean the data, and then just pop it into Clean Influencer Visual to see what it spits out, and then use that as my starting point. Okay. Any questions so far? Okay. I'll keep
Really
going.
quickly,
Mhm.
I'm not sure if Fernando said every time I show the decomposition tree to business users, it has the wow effect. Just a comment.
Yeah, I like that as well. I did have one instance where they had a hard time understanding it, and I think that was only because the confusing part is the length of the bars. That what exactly is this showing me? How is this different from this bar? And things like that. And there are different ways to show that. And once they understood that it's all relative, you can make that relative or absolute. It makes a whole lot of sense. But yeah.
Asks, if I were to introduce key influencers to Power BI developers in my team to train them to identify patterns in key influencers, should I start with Statistics 101 and then key influencers visuals? Are there blog posts, books, or YouTube series you might recommend?
Yeah, so I think what you would do is after this recording, show them this recording, ask them to watch this presentation, and hopefully that will help them, and they won't have to spend a whole lot of time going through the books and other things. Um, but yes, in general, if they have a good handle on statistics and understanding, then it will help. And an example of that is coming up very soon. Tina, how are we doing on time?
We're doing well.
Okay. So the next one is key influencer visual with a measure. Okay. We looked at here the average sales. What if you have a measure? So in this case, I am going to use average sales measure that I've created. And I'm going to drop it in here, and I have the same explain by. I'm just adding just few things here. And then you will often see that when you add the measure, it will say that no segments found, try explain by. And the reason for that is, let me go here and then turn this into a table. Because measures are aggregations, it's aggregating for the combinations, all the different things we have, right? So which means that if you, which means that it's an aggregated level, and we need to break that aggregation. And the way to break that aggregation is by using a unique ID, which you may have from a key, primary key that you have in your data. If you do not, then you will have to um, create an index, which is what I did in Power Query. Sorry, Alex, it will affect the query polling, but um, if we go to row ID, and then we'll go right here. And when we drop it, it should have, oh, sorry, and expand by, it will break that aggregation and then work on the data. Another reason why it did not work earlier, and you will often see this, is it did not have enough data. There is a lower limit to how much data it needs. We don't know what that limit is. But remember, I was talking about the segments, right? So it keeps on splitting the data in different ways. If it is not able to split the data, or if there is only maybe like 10 rows, for example, there is not enough to split, or there's not much information to go by. Or maybe it is all constants. If it is all constants, there is not much variance or variation in your data, then there is not much information. And in those scenarios, it won't work. Okay. So just know that when you're working with the measures, you have to break the aggregation by using a unique ID. So we talked about the key influencer visual, what it means, what are the different settings, different components of that. But if you are somebody who has maybe more statistical background, here is the next slide for you. That how does it exactly work? So this is straight from Microsoft's documentation, which is unfortunately is hard to find. But if you go to Power BI, identifies key influencer, and this is not even housed in any of the Power BI documentation. This is actually in MLNet because under the hood, it's actually using ML.NET to do all the analysis. Okay, and what it does is the beauty of the visual is that if you create machine learning models and algorithms, you have to do a lot of different things, right? You have to create the pipeline, the feature transformations and the feature engineering and a lot of different things to create a model. Power BI is actually doing all of that, and miraculously, it's doing all of that in a fraction of a second. So when you create a clean influencer visual, it takes that, sends it to Insight Service, creates a DAX query, sends it to analysis services, trains the model, gets the results, and all of that, it does that in a fraction of a second, even with a slicer. So when I click on the East, for example, running analysis, boom, it went to that Insight Service, analysis services, trained the model, retrieved the results, and sent you the query back in literally fraction of a second, which is just amazing how it's able to do that. Now, I'm going to skip some of these steps here. This is, again, if you're somebody who is familiar with, um, has a data science background, then this will mean something to you. But basically, again, for categorical variables, it is doing one-hot encoding, doing the imputation, logistic regression, and then for numerical analysis, which is your linear regression, it's doing the fast linear regression, and then providing you the coefficients, the global coefficients as your the impacts, so to speak. So,
Sorry, Cindy, really quick
uh,
question. We had a question to bubble up. Fernando asks, as a developer, do you combine these AI visuals with your own analysis with R or Python?
I do. And I was going to show that, but since you asked the question, let me go ahead and do that. So whenever I do an analysis like this, something like this, I don't take any chances. In fact, let me, even before, because majority of the people even won't be using Python. So let me show you how you can do this in Excel. How about that? So, which is what we're going to talk about next. This is another data set we have here, which is uh, performance. Okay, so very simple data set. We have, I don't know, maybe 1,000. Imagine this is a data set with 1,000 employees. That and this is an HR data set, and HR did the performance rating for maybe the first year, or this could be a quarter. Let's stick with quarter. So the first quarter, that employee got 27 points out of, I don't know, whatever, 100. Year two, it got 50. Year three, or quarter three, it got 52. Um, and then what maybe they are wondering is they come to you and then they say that, hey, is there any way we can create some sort of a HR policy based on this data? And the HR policy could be maybe can we provide more training to the employees, who those employees are, and should we do some sort of an intervention? Can we understand who are those employees who will maybe need more help as to employees who may not need as much help? So how we can leverage our resources to help our employees, right? And the way we can do that is we have a quarter one survey results, quarter two survey results, quarter three survey results, and maybe if we are able to predict what the final fourth quarter in December, end of the year, what their final score is going to be, we can use that, right? Then it says that that particular employee If it is on the higher side, well, they're predicted to be doing they're predicted to do well end of the year. So maybe they don't need as much help, whereas maybe other ones, we will provide them help. So that's how maybe you would use this data. Right? So you're given this data, so you just learned about key influencer visual. You pop that into key influencer visual. It's a numerical, so which means it's going to be increase or decrease, right? So increase or decrease. And then we do that, and it tells us that year three is a key variable, and then year two is one after that. Year one, not so much. Again, this makes intuitively it makes sense as well that employees who will do or have done well in the third quarter, they are already they're good, so they will do well in the fourth quarter. Year two matters as well, but year one, not so much. So what you would get out of this is you will go back to your HR and then say, we should be monitoring year three and then year two, year one. Don't worry too much about it. If somebody is doing exceedingly well or maybe really poorly, don't stress about it. Let's just focus on year two and then year three, and it will we should be good. If we want to, so Fernando asked about how do you basically validate this, right? If you are familiar with Python, you will obviously do this in Python. And we don't have enough time here, but if you are, then you should absolutely do that. But one quick way of doing this is in Excel, and I'll show you how you can do this. And we'll confirm the results that we're getting in Excel as well as in Key Influencer Visual. So I have the exact same data. I will go to data and then data analysis, and then we already discussed that in Key Influencer, all we are doing is running regression, and it's been around for a while, right? So regression obviously is the foundation of statistics, and it's available in Excel. The beauty of Key Influencer Visual is I'll show you what's the beauty here. So let's click on regression, and then let's say the input, what am I interested in? I am interested in this final. Based on what? Based on this input range. Right here. Here. And let's say, yes, I want to create a new sheet and then click on OK. So it will give us an output with a bunch of numbers. And let me highlight a few things that that I want to draw your attention to. Like this, 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 this. Okay. So the first thing that you will notice is it gave us a bunch of values. Unless you have strong statistical background, these may not mean a lot to you. You've been using Excel, all of you, for a very long time. How many times have you used this feature? I'm going to guess not a whole lot of times, right? Which is where the key influencer visual part comes in, because Power BI team has packaged it so well that it's actually giving you the same thing, but in a very nice visual format that's easy to understand for you. And let's see for this case, what we have. So the first thing that we get out of here is the adjusted R value is R squared value is 0.53. So which means 54% or 53% of the overall variance in the final can be explained by the variables, the quarter one, quarter two, and quarter three. Not exceedingly well, but it's not too shabby either. So it's good. It's something we can live with. Look at the coefficients, the betas that we talked about at the start of the presentation. Remember, it's beta 0 with the beta 0 is the intercept, which is this. Then beta 1 multiplied by x, that beta 1 is 0.08 multiplied by x variable. So if we were to create an equation actually out of this, the equation would be this 14.5 plus 0.08 multiplied by this, and so on and so forth. The coefficients here, again, we talked about the betas. Coefficient variable 3 has a beta of 0.87, so which means it is important, followed by variable 2, which has beta of 0.43, so it is second important thing. So directionally, that's exactly what we are getting. We are getting year 3 and then year 2 after that. The coefficient here is 0.87, and the reason why it is 0.87 because it's normalized. It's saying when the x variable goes up by 1 unit, your output is going to go up by 0.87, and which is exactly what we see over here. Look at this. Year 3 goes up 33.49 when this increases by 28.32. So if I take 28.32 divided by whatever 33, you get about 86%, right? So which is what we get, 87% of 80.87. So the things that we are getting out of the key influencer visual, they do match. And this is one way that I would validate the data. Now, if you are familiar with Python, you would the I guess the analogous part in Python would be you can create feature importances using Python or R, which is what I have here, year 3, year 2, and year 1. And year 3 is significantly higher compared to year 2. So you can do the exact same thing using Python or R as well. Also notice that the x variable here, the p-value is 0.25. If any of you are statistics purists, p-value doesn't mean anything, a whole lot, but let's just, that's a different topic, but let's just say it is less than 0.05, the significance value. So these two are important, whereas x variable is 0.25, so not a whole lot important, and which is what Power BI did as well. It did not include that year one, because it is not statistically significant. Okay, so that's what it did. So it corroborates generally what we are getting out of Excel and what you would get Python as well. So it matches. So a high degree of confidence. Where it breaks apart is if you do not know statistics very well, if you do not have understanding of regression and all the data science techniques and all the other things, then you may get misleading results. For example, the adjusted R square value 0.53 from Power BI, we don't know how good it is, right? So in this case, we saw 0.53. So we know 0.53, although you wouldn't necessarily use that value to judge how good it's a goodness of fit measure, right? But Power BI doesn't tell you that. So if somebody, the R squared value may be 0.2, but Power BI doesn't tell you that. Second thing is that because we are using linear regression and logistic regression, those are linear techniques, meaning if you increase it by a certain amount, if you increase it by 1 unit, your output will also increase by that unit. For example, if this variable was age, right? Hypothetically speaking, if this variable was age, and it showed that age is a significant variable in your analysis. And if age goes up by 1 year, then maybe your output of, or maybe it is a sales measure that you're analyzing. Your sales will go up by maybe $10,000, hypothetical. But because this is linear, we cannot say that if we keep increasing by 1 year every single time, like even if the person is 99 years old, your increase is going to be proportionately in that proportion. It's not like going from 70 to 90. You'll go up by 1,000 multiplied by 20. It won't go up, right? So because it's non-linear, that assumption Power BI does not make that assumption, or Power BI is not able to capture or understand that. So you have to keep it in mind that, okay, if Power BI is showing is one of the variables is influential, you have to ask yourself, would that variable be linear or non-linear? And you have to use your business judgment around that. And this is exactly why I wouldn't show this to the business users. I would do that analysis all by myself and then maybe talk to my business users. Another implication of this linear assumption is that in linear regression and logistic regression, the assumption is that your x1 variable and x2 variable, or all the variables, are independent of each other. There is no correlation between the two. We cannot have that. Or there are certain scenarios where they call it confounding or correlation or interaction. Interaction meaning there are two variables, maybe age along with education. As age goes up, your education also goes up to a certain point, right? So age and education, for example, those are interacting variables. They go hand in hand together. So if we wanted to increase, if I were to do this analysis in Python or R, the question, and if I'm doing this, one of the things that you would always explore are there any interaction terms in your analysis? So an interaction term in our case would be, what if I took as one of the ways is, what if I took a product of year two and a product of year two and year three. So in this case, this column C, so my year two score is 50, year three score is 52, and I take a product of those two, and then this, right? In business sense, it won't make any sense. In a BI report, we absolutely won't do that. Does not make any sense at all. But let's take a look at it and see if that's really the case. If I again go back to regression, and then I say, hey, take this final result again, um, final result again, and then take my x, which in this case is this, and then create a new sheet, and then OK. Now notice my R squared value jumped up from 0.53 to almost 60%, which is significant, right? That's a significant increase. Just adding that one variable increased the overall accuracy of the model. And on top of that, look at the coefficients. Those have changed. And not only that, the new variable that we added, this x4 variable, it is more significant, it is more influential than any of the other variables. So does that even make any sense? It does in this problem, because what it's saying is that we multiplied year two by year three, or this quarter two by quarter three. What this is saying is, what matters is not only your third quarter result, what matters is not only your second quarter results, but how you go, what is your overall increase going from quarter two to quarter three. So your policy would be not only track the people or employees who have high scores in those quarters, but look at their improvements or look at their deltas as well. Now, if you are doing that analysis in Power BI, there is no way that you would be adding that in here and doing the analysis. If I were to add that, in fact, here, I think I do. Do I have that? Yeah, let's do that. Yeah, there you go. So Y23 now went up. So that's the most significant variable more than anything else. But in your traditional BI report, you wouldn't be doing that. So the point of saying, or point of showing this to you is that um, there are nuances to this that you should understand, that not everything that you see are is an absolute truth. You'll have to spend a lot more time, but it at least gives you a direction. It at least gives you pointers to understand that maybe what is the next step that you should take into account. It could be Excel, it could be R, it could be Python, or no, it could be anything else. Tina, how much time do we have? Just want to make sure.
We usually wrap up before 7, so if you want to leave some time for questions, it's kind of up to you how much time you'd like to take.
7. So,
Oh, so about
how many minutes?
25 minutes.
Oh, okay,
or so.
okay, yeah, that's good enough. Any questions so far? Okay. So I guess the takeaway here is that yes, use the key influencer visual, but at the same time, use it with caution. If you do understand statistics, it will make it even more easy. It will make it easier for you, and it will help you. In fact, for a lot of my data science projects as well, I take the data and then put it into key influencer visual and see what do I get, because that is a good enough starting point for me to understand where should I be spending my time on, and then looking at which variables and which features and things like that. Okay, let's see what else. Edge cases. So we'll keep talking about where you wouldn't use key influencer visual. And I would like to show you some examples where it does not work. So we have some data here. Is it the same data? Oh, this is a different data set where I artificially added some outliers in the data. Outliers meaning some data that does not make any sense, like a million where the age is a million, or something like that. I also added some missing values in the data and some multi-collinearity in the data just to test how robust the key influencer visual is. Now, again, if you're doing this in Python, um, you would do the exact same thing. So let's say without an outlier, this is what you will get, 92.26, right? With an outlier, when I do that, so I added something here, and let me lower this, and you will see that you will get a different number. So 8511, 9193, and then 92 and 103.1. So the purpose of showing you this is you your data has to be clean for the clean influencer visual to work, because again it is a linear because of the linear assumption. If that falls apart, then key influencer visual will give you wrong results. Also, the other implication of that, don't take these values that you're getting out of the key influencer visual as hard numbers. That yes, it is going to go up by $103,000 or 103,000 units. Use it as a direction. Use it as a more of as a ratio to say if it goes up by 1, then it goes up by this much amount. I am not 100% sure why Power BI chooses to show it as audience goes up by 9193.72. I don't know where it comes up with that number, 91.9, 9193. I've tried to find it and make sense of it, but I cannot understand where it comes up with that number. Like, what is the threshold it uses to say, and why not just make it to say that if audience goes up by 1, then it will go up by this and this. So I don't understand that. But the takeaway here is, don't use these numbers as hard numbers. Use it as a direction. Using missing values, so I deleted some of the values and artificially created missing values in here. So if your data is not clean and has some missing values, key influencer visual will not give you any errors. In fact, worse than that, it will actually impute the values. So if I go back to the architecture, you'll see that it says replace missing values. So it will actually take the values, and then it will take the mean of the column, and then replace wherever it sees missing values in your data, it will replace it with the mean value of that column. Okay. And then give you the results. But I think it should show you it should at least warn you that it is doing that, but unfortunately it does not. And the documentation, in fact, doesn't say anywhere about that either. Multicollinearity. So this is again one of those things where we talk about having the assumption with the linear regression is that all the variables that we are putting in here, those are independent of each other. So, for example, maybe if I add income and education, as your education goes up, generally speaking, your income also goes up, generally speaking. So there might be some correlation between the two. Because the assumption is they have to be independent of each other, we would be taking one of those things out. Now, I should say again here is that Power BI does take some of that into account. And the reason I know that is because it uses this logistic regression with some regularization with this LBFGS. So I know that it does try to guard against that so that you don't have to worry about it. But again, that it's something it doesn't tell you. So it might pick. So for example, it might be if you have income and education, if you drop both, it might pick in income and then say income is important. If you do the analysis again, it might pick education because that's how the algorithm works, the regularization works in the back end. Um, and it might give you that. So again, you have to understand your data a little bit there. Outliers, same thing. That if you, I think we talked about that already. I forgot what I was going to show here. Oh, the outlier too. Then there might be not outliers, but there might be influential observations. And the difference between the two is outlier is something that does not make any sense. So the age being 999, right? That wouldn't make any sense. But in this case, for example, whatever this audience is, I think this is number of audiences. We have certain observations here. So I'm trying to predict uh, who would buy the number of, I think, page hits on a website based on audience and income and if they're male, female, and things like that. In this case, for example, if you look at it, we have these points over here, and then we have 3 data points that are on this side, right? Now, these are not outliers because it's not like you can completely rule it out. This is something that exists, it's real. But again, because this is a linear regression, the linear regression will be influenced by these factors. And I can show you that. So right now, if we see that this is it's about 30,000, right? So if I go here right now, it is 91, 93, and 92. If I reduce it below 30,000, that number is going to change. I forgot what this was. 91, 93. If I reduce it below 30,000, that number changed to 64 or 24. So it found a different line and then it did that. So again, you have to keep those things in mind. And a typical business analyst or data analyst may not understand that. And that's where the key influencer visual starts to fall apart. So if you're using it, my recommendation would be that use it, but use it cautiously. And what I would use more for is these segments, because these segments, there is no AI thing going on here. There is no linear regression, there is no logistic regression, there is nothing going on. It's just splitting the data lots of different ways and giving you the distributions and telling you where those segments are. I would still use this to influence my own discovery process. Like where should I focus on and what should I do in terms of the hierarchies, the slicers, and what should I present. and what should I talk to my business user about, and things like that. And maybe they even they don't understand, right? So things like that. But I wouldn't use this as a hard truth, and then use that. So the key takeaways here, always understand your data, do your exploratory data analysis, and understand the data. Make sure your data is clean. It doesn't have any missing values, doesn't have any outliers, doesn't have any influential points. Impute your missing values. If you spend a little bit of time on understanding the statistics, going through the statistics, it might help you even more. If you know how to do it, use Python R. If it is just linear regression, then definitely use Excel. And then keep in mind that correlation doesn't mean causation. If something is shown here, it doesn't necessarily mean that it is causing that, right? So just keep that in mind. One thing that is not very well known, and Power BI documentation doesn't highlight that either, is actually the key influencer visual works only on 30,000 data points. So if you have 10,000 or if you have a million rows, theoretically speaking, that's good because you have the more data points you have, that's better for analyzing the patterns. But it will actually randomly sample 30,000 data points from your overall data. And that is just for speed purposes, right? It doesn't want to spend a whole lot of time and to get the results back. So it will sample 30,000 data points randomly and then create those um, uh, the impact scores and everything for you. The uh, the decomposition, I don't think it has such a limitation. Uh, I don't think so. It takes into account everything that you throw at it. It will obviously slow down, but it does take all of that data into account. The implication of that, again, going a little bit technical here, the implication of that, if you have an imbalanced data set, meaning if you have loan default, for example, that out of all of these million customers, um, uh, there might be maybe only I don't know, out of a million, maybe 100 default on their loan. You wouldn't use key influencer to understand something like that because of the skewness in the data. The linear regression, logistic regression, they don't handle that thing very well. So it won't work that way. If you're looking at the categorical that we talked about, meaning the return is 50%, not returned is 50%. So even the case that I showed, our overall return was 1%. So it's actually not a good scenario to use key influencer visual. So keep that in mind. Only include the key influencer visual if you can explain the results very well. And hopefully by the end of this presentation, you will be able to explain that, or at least you will know what the limitations are so that you can spend more time to understand your results and understand your data and then uh, uh, use it accordingly. And then read the documentation. I don't think they have made any updates to the key influence visual. Not that I know of, at least. But yeah, read the documentation carefully, understand the limitations and where exactly you should be using it, and then make the best use of it.